All right, guys, so let's take up this question. Very straightforward. We are given that these ratios, they are equal, and they involve these variables x, y, and z, and there is one unknown k present here. And then we are given this equation that x cubed y squared z is 1, and using these we have to pull out what is the value of k. So let's work around this. So since we have this thing, let's equate it to some lambda, because these ratios, they are equal. So let's call this ratio lambda, so that we get three separate equations. One is when I will equate this with lambda. So let's write it here. So from here, comparing this with this, I get that log x base 2 is 4 lambda. And then if I compare this thing with lambda, I get log y base 2, that is 6 lambda. And with this third one, we get log z base 2, that is 3k lambda. And since we have this thing, so we can substitute the values of x, y, z here. For that, we will pull out the values of x, y, and z from here. So we remember, since x is hidden here under this log, so we know how to remove this log. So we'll notice what is the base of this log, that is 2. So we'll apply the same base both the sides. So let me put it here. So I will put a base 2 here and a base 2 here. So equality will come down a little bit. So this thing will cancel out, because this is these things, they are inverse functions, and we are left with the value of x, which is x is 2 power 4 lambda. And doing the same thing here, just quickly applying the base, this will cancel out, and we get the value of y. So that is going to be 2 raised to power 6 lambda. And doing the same thing here, this cancels out. So z is going to be 2 raised to power 3k lambda. Oops, oh no. 3k lambda. All right. So once we have this, we'll just plug these values in the second equation. So let's bring them here. So I have 2 raised to 4 lambda as the value of x whole cube. Then I have 2 raised to 6 lambda, and that is that thing is square. And then I have 2 raised to power 3k lambda. And that thing is given to be 1. So that means 2 raised to power 4. This is going to be 12 lambda plus another 12 lambda from here plus 3k lambda, that is 1. And since 1 is just 2 power 0, 2 is a valid base. So just equating the powers, 24 lambda plus 3k lambda, that should be 0. Which just means that if I pull out lambda, so I get 24 plus 3k, that should be 0. So this just means either this is 0 or this is 0. So let's go back to this thing. So this can be 0. I mean, this ratio can be 0. So because if this is 0, then x will be 1. So let me put a clause in this question to make it complete. So let's say that we are given that x, y, and z. Let's write it this way. X, y, z, they are not 1. None of them is 1. Because if x, we remember that log of 1 is 0. So if any of them takes value 1, then that will ensure this ratio is 0, which we don't want, so that it must have a finite answer. That's what we are ensuring. So I have added this clause to the question. So now we have these 3 things in the question. Given these 2 things, these 2 statements, and this condition on x, y, z. And under that, now we are sure, because x, y, z, none of them is 1, so lambda cannot be 0. So since lambda cannot be 0, so 24 plus 3k must be 0. And that gives us the value of k, which should be minus 8. Right, so plain simple. So these were logarithmic equations, and we see in these portions logarithms were involved, and we just got rid of logarithms by applying appropriate bases. And once we got rid of logarithms, we just plugged in these values in the second equation and we obtained the value of k. So very basic properties of logarithms. Right, so that's it for now. Bye-bye.